Unit 6, Section 3. In this video, we're going to do examples A, B, C, and D. So these are going to help us explore what we just talked about in the last video in regards to scale factors and what they mean when we have different dimensions. So, first example, given these two similar triangles, it's going to ask us some different things about the scale factors. So I'm going to decide right away that this is going to be my new triangle and this is my old one. So I'm blowing it up. I'm making it bigger. So the first question is, what is a scale factor? So I do new over old. So it'd be 6 over 3. Or I could have said 10 over 5. So I look at those side lengths and I see on the similar triangles, make sure I have the kind of the corresponding ones, and then I put them new over old, and I can simplify all the way down to 2. So our scale factor is 2. Now what's the perimeter of ABC and the perimeter of the other one, and how do those compare? So it's going to ask us to find the scale factor. Well, I'm missing the hypotenuse of both of them, but I see they're right triangles, so I can use Pythagorean theorem to solve. So I know a squared plus b squared equals c squared. So a squared and b squared, a and b are the legs, so these two shorter sides, and the c is the hypotenuse. So I'm going to say 6 squared plus 10 squared equals c squared. 36 plus 100 equals c squared. 136 equals c squared. And if you plug that in your calculator to do the square root, you get that c equals 11.7. Do the same thing for this one. 3 squared plus 5 squared equals c squared. 9 plus 25 equals c squared. And then if you plug that all in your calculator, you get that c equals 5.8. So I'm just going to write that in, that this is 11.7 and this is 5.8. So the perimeter of triangle ABC is adding up all the sides. So I do 6 plus 10 plus 11.7, which will give us 27.7. And the perimeter of triangle DEF, add up all the sides again. You just have to make sure you know what you're doing. Am I finding perimeter or area? And so I'm finding perimeter, so I just add up all the sides. 3 plus 5 plus 5.8. So I get the distance all the way around that triangle, and I get that to be 13.8. And so I did it on purpose here. I have new over old, so I would just do a fraction of 27.7 over 13.8, which if I put that in my calculator, I get really close to 2. And so I think, is it okay that's a little off by like 1/100th? And that is okay because if I remember over here, I rounded. And so I'm going to have a little bit of rounding error, so that should be okay. As long as it's really close to 2, then that should be fine. So the scale factor are the same. Now what's the area? And we remember area is 1/2 base times height. So area of ABC equals 1/2. Our base is 10 and our height is 6 since it's just a right triangle. So 10 times 6 is 60. Half of that is 30. And then our area of triangle DEF equals 1/2. Base is 5, height is 3. 1/2 of 15 is 7.5. Once again, if I put those one over the other, I get that to be really close to 4, which is k squared. Once again, I'm a couple hundredth off, but that's from, well actually, I think it actually comes down to be exactly 4, so, which is how it should. So that concludes that example. If we look down here at example B, which is with circles, we have these two similar circles. So it says A similar to B. Once again, I'm going to pick right away which one's my new, which one's my old. It doesn't really matter which one you pick, but it's good to pick just so you're consistent for your scale factors. Now, what is the scale factor? Well, I can just use the radius here of new over old, 5 over 2. So I don't need, since even, I don't have side lengths for this, but the radius works just the same. And we're going to see, what if we had used circumference? Will that give us the same scale factor? And we will see. So if we have circumference of, my new one is A, we remember circumference as pi times d. So d for A is 10 because our radius is 5, so we do 2r. And circumference of B is 4 pi, so I had to double the radius. If we do those one over the other, I can cancel out the pi's and simplify to be 5 over 2. So that does in fact equal our scale factor. Here we're going to do area. I'm going to do that. And when I see area right away, I think it's probably going to be k squared, but we will see. So let's see, I'm going to do it right over here since we don't have quite enough room. So area, remember, is pi r squared. So we think of, let's see, area of A. So pi and then r squared. So I'll just write it out like that, which would be 25 pi. And area of B equals pi r squared. That'll be 4 pi. One over the other, get rid of the pi's, and I don't think I can simplify 25 and 4 anymore. But that works out well because that is in fact our k squared, because we have 5 squared over 2 squared. Next, let's see, I'll wait till the next video to do the next 2 examples. So those are examples A and B. Stay tuned for examples C and D.